Good day, student. Today, I want to discuss a topic on the homogeneous differential equation that involve substitution of y equals to vx. We are going to see several examples on that. We have discussed on that examples in our previous classes, and what we are going to discuss today is based on when an expression is put close to dy over dx, especially when you're having uh, power of 2, x is raised to power of 2 and y raised to power of 2. The addition of the two expression, which is x squared plus y squared, is being placed close to dy over dx. We are going to remove that by dividing both sides by x squared plus y squared. Now let's see what's on the board. We're having x squared plus y squared dy over dx equals to xy. What we need to do here is to divide both sides by x squared plus y squared. X squared plus y squared. Whatever you do to the left hand side, you do it to the right hand side so that you can cancel the expression close to dy over dx. It's just cancel out. You are left with dy over dx equals xy over x squared plus y squared. This is the expression for dy over dx. Now, what we need to do is that we are going to substitute y equals to vx. Anywhere you say y, you replace that with vx. Okay? Now, you have dy. Okay, let me say substitute, substitute, substitute y equals to vx. Let's call this one equation 1. Y equals to vx in equation 1. When you do that, you're having dy over dx equals x multiplied by vx, because we replace that with vx, over x squared plus y is being squared. You're having vx open bracket and close squared. Now x times vx, that's x squared v as x squared v over x squared plus x squared v squared. Okay, you can still write it making v to come before x. Okay, still the same thing. We're having v squared x squared. We now have dy over dx equals x squared v over, let's factorize x squared. We're having x squared x squared. Let's factorize it out. X squared is common. Open bracket 1 plus v squared. Now x squared cancel x squared. The y dx equals v over 1 plus v squared. Good. This is the expression for the y over dx. Let's call this one equation 2. This expression for the y over dx, you now go back to what you are substituting, which is y equals to vx. You differentiate it using product rule. You can now say differentiate y equals to vx using product rule. And the product rule goes thus: dy over dx equals, you keep this v and differentiate x. And we are differentiating it with respect to x. That's the v v equals dx over dx. Okay, we now keep this x and differentiate v, dv over dx. Please take note, this is what we call product rule. You keep this v and differentiate x with respect to x, plus you keep this x and differentiate v with respect to x. Now, what you need to know is that dv over dx, it will not change, it will remain like this. Why? Some students get confused that why do we differentiate x and we didn't differentiate v, we leave dv over dx is being left the way it is in the expression. The reason why is that there's no guarantee that dv over dx is equals to 1, because v may vary may vary at any rate with respect to x. V may vary at any rate with respect to x. That's why it's being left the way it is. But there is a fixed guarantee that the x is equals to 1. There's a fixed guarantee that derivative of x is equals to 1 with respect to x. Okay? This the reason why we're unable to differentiate, let me explain it again. The reason why we're unable to differentiate, we left this dv over dx the way it is in our expression, is that v, there's no guarantee that dv over dx is equal to 1, because v may vary at any rate with respect to x. Since it varies at any rate with respect to x, there's no universal value for it. But in the case of x, only x itself has a fixed guarantee. Is okay? There's a fixed guarantee for the derivative of x. Derivative of this x is equal to 1. There's a fixed guarantee that the derivative of x is 1 with respect to x. That's why when you differentiate it, it will give you 1. What you are saying is that when you're having y equals to x, when you differentiate it, before then, let me give you the general formula for that. Y equals to ax raised to power n dy over dx equals a dot n x raised to power n minus 1. Now, when you now have y equals to 1, equals to x, when you're having y equals to x, when you differentiate it, we're having dy over dx equals, this one will come to the front. Don't forget that we have 1 here before. 1 times 1 x raised to power, there's 1 here, 1 minus 1. You're having 1 times 1, which is 1, times x raised to power is 0. Anything raised to power 0 is 1. That's 1 times 1 equals to 1. You see now that when you differentiate x, you have 1. When you differentiate x, you have 1. Now, you now have dy over dx equals to v multiplied by 1 plus x dv over dx. Dy over dx equals to v times 1, that's v, plus x dv over dx. This is our equation. We have equation 2 here already. This is our equation 3. What you need to do now, you can see the expression for dy dx. When we made some substitution, we have dy over dx to be equal to v over 1 plus v squared. And what we are substituting, when we differentiated it with respect to x, we had this expression dy over dx to be equal to v plus x dv over dx. You now equate the two expressions together because they are both expressed as dy over dx. You can now say equate equation 2 and equation 3. Equation 2 and equation 3. When you do that, you now have v plus x dv over dx equals to what you have here, v over 1 plus v squared. Okay, now take v across the equal sign. Is positive before it turns to negative. X dv over dx equals to over v over 1 plus v 1 plus v squared minus v over 1. Okay, from here we are going to find the LCM. Look for the LCM. Let's look at the way I'm doing it step by step. Very easy to solve. And let's now have x dv over dx equals to, what's the LCM? Our LCM is 1 plus v squared. Now, 1 plus v squared and 1 plus v squared is 1. 1 times v, that's v, minus 1 goes in 1 plus v squared, that's 1 plus v squared times v. You have v into, you have v already here, into 1 plus v into minus v into 1 plus v squared. You now have x dv over dx equals v. Let's open this bracket. Minus v times 1, that's minus v. Minus v times v squared, that's minus v raised to power 3 over 1 plus v squared. Very simple expression. And when you look at what we have in here, you have plus v minus v, it cancels out automatically. You are now left with minus v raised to power 3 over 1 plus v squared. That's as x dv over dx equals minus v raised to power 3 over 1 plus v squared. Can you see what you are doing? We are following it systematically. When you get to this point, we want to do in such a way that we're having separation of variables. And we want to, in terms of x and v now, let x comes to one side and v move to the other side. In my own case, I want the v to come to the left hand side and x to go to the right hand side, so that we can now involve what you call separation of variable. By the time we do that, it will be very easy for us to integrate in terms of dv and dx. Okay, now let's now see what I want to do now. I want to cross multiply. You cross multiply like this. Now you're having x. You can see the x. I'm now putting this 1 plus v squared. I try to separate x because I will still cancel x out. I want the v and the dv to be together. Any way you write it, it's still the same thing because it's multiplication. When you're having 2 times 3 is 6. Or 3 times 2 is also 6. Whether you put it at the front or at the back, it's still the same things. They are both, they are multiplication. You are multiplying them together. Now you're now having x 1 plus dv, 1 plus v squared. Dv will now be at the end because we are going to integrate in terms of dv and dx. Now you now have it to be equals to, we are left with this, you cross multiply, you are left with dx, you multiply with minus v raised power 3 minus v raised power 3 dx. Now at this point, we are going to remove minus v, we are going to remove v raised power 3 from the right hand side because it's not in correlation with dx. is in correlation with dv. Now divide both sides by v raised power 3. V raised power 3. This v raised power 3 will now cancel v raised power 3 out. You can see that this x shouldn't be at this side. We are going to take it to the right hand side. But let's write it out so that it will not mix up. Now you're having x into 1 plus v squared dv over v raised power 3 equals minus dx. This x shouldn't be here. Divide both sides by x. Divide both sides by x. Now x cancel x. Okay? X cancel x. At this point, what you are left with is 1 plus v squared over v raised power 3, or open bracket and close the v, equals to minus 1 over x dx. Okay, there's 1 at the numerator here. You try to separate it from dx so that it will be very easy for us to find length of x. Okay, now what you need to do, since you have separated everything to be in terms of v and x, it's very easy for us to integrate. We have done the separation of variables. Now integrate both sides. Integrate both sides of the equation. Now we are integral of 1 plus v squared over v raised power 3 dv equals minus integral of 1 over x dx. When you get to this point, you can see that this v raised power 3 is common to both 1 and v squared. Is dividing both 1 and v squared. Let's separate them. Now having integral of 1 over v raised power 3 plus v squared over v raised power 3 is common to both dv. Okay, equals to minus integral of 1 over x dx. Good. Now, when you get to this point, under indices, when you are removing this 1, it will now turn to integral of v raised power minus 3. You introduce the negative, and this v square, it will cancel to v square inside this v raised power 3. You are left with 1v. It now become 1 plus, because it become plus 1 over v. Okay, it's like when you're having v square means v times v, and v cube means v times v times v. 2 of the v cancel 2 of this v. You are left 1 over v. That's why we got 1 over v here. The integral will now be integral of v raised power minus 3 plus 1 over v dv equals minus integral of 1 over x dx. Okay, we now apply the rules of integration by removing this integral. When you do that, you now have v raised power minus 3 plus 1 over minus 3 plus 1. Okay, the power will be repeated down. Just bring it down. Minus 3 plus 1 over v raised power minus 3 plus 1 over minus 3 plus 1 plus ln v. Ln v. Ln v has taken care of the integral of 1 over v. When you differentiate v, you have 1. But in this case, if you are looking for the integral of 1 over v, just write ln v. Ln of the denominator is same thing as integral of 1 over v. Okay? Now, you now equate it to minus ln x. Okay? At the right hand side, when you put ln x, you now add your constant plus c. Plus c. At this point, uh, you let's add the minus 3 plus 1, that's minus 2. Now v raised power minus 2 over minus 3 plus 1, that's minus 2, plus ln v equals minus ln x plus c. Now, in this case, we want everything to be in terms of ln, where c equals to ln a. You now replace your c with ln a. Okay. Now, this v raised by minus 2, it will come down. When it comes down, the negative will disappear. Okay, let me write it very well. Now be minus 1 over 2 times v raised power minus 2. I'm trying to separate them. We're having 1 over minus 1 over 2 here, plus ln v equals minus ln x plus, instead of writing c, put ln a. Okay, we just assume c to be ln a so that everything be in terms of ln. Now, this v raised power minus 2, v raised power minus 2 equals 1 over v squared. In indices, it will now be minus 1 over 2 v squared. Okay, this v squared has come down, plus ln v. Now, let this minus ln x come to the left hand side, plus ln x. We want all the ln to be in one side, minus ln a equals to 0. Let's take minus 1 over 2 v squared to the right hand side. We're having ln v plus ln x minus ln a equals to 0 plus, turn to positive when you cross the equal sign, 0 plus 1 over 2 v squared. Okay? Now, where ln k equals minus ln a. We want everything to be in terms of multiplication. That's why we want to turn this ln k to be minus ln a. Ln v now plus ln x. Instead of writing minus ln a, now say plus ln k, because we have represented it with ln k, equals to 0 plus 1 over 2v squared, as 1 over 2v squared. Good. Now, everything is in terms of positive. In indices, you turn it to multiplication, you pick one ln to represent all. It now be ln v x k equals to 1 over 2v squared. Okay, in indices, when you use ln to represent it, you now write the other ones in terms of products. Now, when you get to this point, don't forget that our y is equal to vx. Let's make v the subject of the formula, because we are going to replace our v back. It has to be in terms of y and x. Now replace, because all this v is when we made assumption. Is that okay? When you do some replacement, that's when we have it as v. We want to replace it back. Now substitute. Substitute it into this expression. Okay, let's call this one equation 4. Substitute this one. Let's make v now here equals to y over x. Substitute v equals to y over x in equation 4. Okay, when you do that, you now go back, lane. This is our v, right? Y over x multiply by x multiply by k equals to 1 over 2. Instead of writing v squared, you replace it with y over x, y over x. But don't forget that v is being squared. Now close the bracket and square it. This x cancel this x. You are left with ln yk. Ln yk equals 1 over 2. This y squared over x squared. Don't forget that this expression goes together. Now, when ln yk, because this one will be 1 over 1 divided by 2y squared over x squared. And don't forget that when you are changing division or multiplication, the denominator will go to the numerator and numerator will come to the denominator. Now having ln yk equals 1 over 1 times x squared over 2y squared. Ln yk equals 1 times x squared, as x squared over 2y squared. Okay, now you cross multiply from here. This one is over 1. Cross multiply, you're having 2y squared ln yk equals to x squared. That's the expression. We have now made it to be in terms of y and x. Okay, this is the end of our class. Please subscribe to my channel so that you can have access to the latest video. And also, if you want an online class, you can also chat me up so that we can arrange class together from any part of the world. Have a wonderful day.